Hi everyone, in this presentation we'll be talking about the ASDSO dam model competition. My name is Sohan Sadek.
My name is Sarah Feroz.
My name is Sally Feroz.
And my name is Alina Sadek. We have been family friends ever since I was born.
I came to know of this competition back in October 2021 after my dad told me about it. It sparked my interest since I had prior experience with the topic, and I decided to include some friends and family to make it a more enjoyable experience.
This is Cleveland Dam, located in North Vancouver, British Columbia. This is where we get our clean drinking water from. Here's the overflow spillway. Did you know a deadly incident occurred when a sudden release of water about 3 meters high killed a father and son while they were fishing?
Here are the two people that died because there were no warning siren. This was our motivation.
Before we submitted our application, we observed Ruskin Dam, which is close to where we live, through Google Maps. We began to get a sense of how the dam looks, as well as the floodplains that surround it. We then drew our sketches with inspiration from the dam to express our ideas, and also began to think about the materials that we would use and where we would find them. We also checked the cost and began to think of a timeline of when we could work on this project together. After all of that, we submitted our application.
Our objectives for this competition were to build a dam model and conduct experiments, learn about dams and their impacts on the environment and the community, learn about public safety measures, and we also strive to share our knowledge using a model display. Finally, we strive to increase public safety awareness.
Here's a sketch of the full model taking inspiration from both Cleveland Dam and Ruskin Dam.
This sketch shows the full circulation of how the water would flow throughout our dam. Here's a sketch of the full model.
ASDSO liked our ideas and our sketches, so they announced us as winners.
Upon winning, we took a trip to Ruskin Dam, which is a dam near Vancouver, BC. It inspired the design of our model and also informed us of precautions already put in place.
After our trip to Ruskin Dam, we started shopping. We went to stores such as Michael's, Dollar Store, and the Home Depot to buy materials and decorations for our dam model.
Next, we started preparing the wood, painting, drilling, and hammering, and then gluing pieces together.
Here's an image of us finishing up the final touches of our model. Here's the overall framework of our dam. Here we have the dam, the reservoir, and the sump. Water will flow from the sump in the reservoir and down the dam slope. Here we have the tailgate, which we will use to model high and low flooding conditions. And this is the base of the river, where we will later, as you will see, build the floodplains, which will include some houses, some farms, and even some parks. After we completed the framework, we checked for leakage. We found a couple, so we covered them up with silicone. Then we checked the pump flow, as well as the sump's capacity and how many buckets of water were required to fill it up. We checked if the model works, and most importantly, began to familiarize ourselves with all of its components.
As you can see, Sohan is applying some glue to place the styrofoam onto our model. Here we are cutting the styrofoam into the shape of a river, painting, and as well as adding plumber's putty onto our model. Here we are placing a green mat to represent grass for residential areas and parks. We are also starting to add some rocks and decoration pieces for our model.
This is our completed model. You can see a dam, a reservoir, a spillway, a powerhouse, a river, a fish spawning channel, some homes, a farm, and a park. Here's another angle to show you the fishermen fishing along the river. Let us show you a video of how our model runs. This is our model. It is made out of plywood. Here we have a sump, which holds all the water for the model. And from there we have a pump, which pumps the water into this reservoir. From the dam, we have 3 ways to release water into the floodplain. On normal occasions, we'll be using the 2 penstocks attached to the powerhouse. We also have a low flow outlet over here, and an overflow spillway up here.
As Sohan mentioned previously, here is a pump which will bring water into the reservoir. Here we have the powerhouse, so under normal conditions that will work, but suppose the powerhouse is not working, we will open up the low-level gates so then it can bring water back into the river so the fish in the fish spawning area will not die. Under flooding conditions though, the water will be able to completely fill up the reservoir and spill into the overflow spillway. All this water will go back into the sump, which the pump will bring back into the reservoir and it will recirculate once again.
Once the water comes out of the dam, there are two ways that it can go. One way is the main channel, and the second way is the side channel where fish spawn. As you can see, there's parks and fishing areas at low elevation.
Besides the river, there are homes, a farmhouse, roads, and a forest. In normal conditions, people would come down to the park to go fishing, sit down at a bench, or they would stay at their homes. But if there was a flood, they have to know ahead of time so that they can be safe.
In normal flow, we'll be using the powerhouse to generate electricity. If there's an issue with the powerhouse, with the low flow outlet down here, keep the minimum amount of water in the river to keep the fish alive and keep the river wet. Overall, in normal flow conditions, water will be maintained in the river and normal life should not be disturbed.
For those people that live or come to this park for fishing or a picnic, they are already warned by these signboards telling them about the high risk of a flood by the dam. If there is a flood, then the dam owner will send a alarm going like this. And then they will evacuate as fast as they can to be safe and from this flooding area.
Right now we are modeling a minor flooding condition. As you can see, the water has flowed over the banks, and anyone who is in the park recreational area, such as this fisherman, as you can see his feet are kind of under the water, they are unsafe. And as Alina has previously mentioned, we have signs here kind of helping people be aware of this danger and make sure that they are safe in case of the scenario.
Sarah just showed minor flooding, but the water can reach even higher. As you can see, in the dam, the reservoir level is so high that the dam is overflowing. This causes residential area and farms to flood. This can be very dangerous, and before this occurs, dam owners must warn residents so that they can evacuate and be safe.
The most important aspect of this whole journey and building this model was to familiarize ourselves with the different safety components that are put in place to ensure the safety of everyone living around dams, as well as public recreational users. Some public warning and alarm systems may include some signboards with sketches or pictures, acoustic warnings such as sirens, bells, or whistles, as well as visual warnings such as strobe lights and flashing lights. In 2021, 6 audible and visual alarms were installed along Capilano River in North Vancouver near Cleveland Dam in response to the 2 people that were killed because of the dam. Some ways to make people familiar with these warning systems include putting them in local newspaper, leaflets, and place cards, radio, television, and social media such as YouTube or Instagram, and demonstration of emergency drills for residents around the area as well as recreational users, and what we're doing right now, ensuring that we know and are knowledgeable of the different safety components and make sure we share them with everyone around us.
Lessons that we learned and takeaways. It was fun to build the model.
We learned how a dam works as well as its components.
We learned how to be safe around dams.
And most importantly, we will continue to share our lessons at school, in social media, and within our community with our family and friends. Our ultimate goal was to increase dam safety awareness, both within ourselves and with those around us. And we can successfully say we have done that.
Thank you.